Thanks, Rupam. I will briefly review our exploration of the COVID-19 outbreak in India based on this modeling framework. We examined 5 different scenarios, 2 without a lockdown period and 3 with a lockdown period. First, we looked at a no intervention scenario wherein we didn't impose any changes to the effective reproduction rate via that pi-t parameter that Rupam was talking about. And then also a social distancing and travel ban scenario where there was sort of a small but perpetual reduction in the effective reproduction rate. And then we also looked at 3 different lockdown scenarios based on a 21-day lockdown period. And these 3 lockdown scenarios differed only in the level of activity that was returned to after the lockdown was lifted. A moderate return, a cautious return, and a return to pre-intervention levels of activity. India had since announced subsequent lockdown extensions of 40 and 55 days, which we'll return to in a few slides. But first, this is sort of a helpful visualization to look at the effective reproduction numbers under the different scenarios. That yellow line represents the social distancing and travel ban, which remain constant over the entire observed period. And then we have 3 lockdown-based scenarios. That dark blue on the bottom, we see a small increase after the lockdown is lifted. And then we see a more moderate return by that light blue line, and then a normal or pre-intervention level return with that teal line. And then these are our short-term forecasting results based on observed data through April 14th. What we see is that there is obviously a more marked increase under the no intervention scenario in red, and that we see a short-term benefit to the social distancing and travel ban lockdown, and an even greater reduction in predicted cases under the moderate return scenario. We provide the 95% upward credible limit for that lockdown scenario, which just highlights the high level of uncertainty that is incorporated into these models, particularly the farther out that we go. Looking at that box in the upper right, we can see some of the estimates on April 30th under the 3 different scenarios that are presented in the graph. As we can see, now that we have obviously observed April 30th, that we underestimated the number of cases on April 30th under that lockdown scenario, but it is well within that upper credible limit. And then on the next slide, we present some of our longer term forecasts. This is looking at the number of incident cases under 4 of the scenarios, the yellow line representing the social distance and travel ban scenario with the constant effective reproduction rate over the observed period. And then again, the 3 different post-lockdown activity levels. Cautious return obviously would be, we see the lowest predicted number of cases over the time period, and then a more moderate return. And then we do see under all 3 lockdown scenarios a short-term benefit compared to the social distancing and travel ban scenario. But we see that if after the lockdown is lifted, activity returned to pre-intervention levels, that we see that benefit kind of disappear altogether. Whereas under the other 2 scenarios, we see that benefit maintained over the entire time period. And then on the next slide, we also looked at the length of lockdown. So again, the initial lockdown was announced for 21 days, and then was extended to 40 or so days, and then 55 days. And as you would expect, that the longer that lockdown period persists, the greater the benefit that you see. We do see that the peak is obviously occurring earlier in these shorter lockdown periods, So we're kind of seeing that nice flattening of the curve that everyone talked about in terms of these non-therapeutic interventions. But again, we do see some marked decreases in the expected number of cases over the time period. And then I'll pass it off to Brimar to talk about some of our sensitivity scenarios.